example, do one of the questions in the book. It's the one I looked at yesterday with Riley, and I want to suggest some ways to attack it so it's easier to do. The first thing you always do is you read a question, you draw it, and you put your data in. That's just essential. So I'm looking at projectile problems 3, question 2. And what it says is that you have a cliff line, and a projectile is fired from the top of the cliff, and the cliff is 120 metres tall, top to bottom. And it's fired at 25 metres per second at some angle, which we're not told. And of course, having it fired off like that, it'll follow some trajectory. It's going to land some distance from the cliff, which I don't think we're told. Yeah, question 2, and lands after 6.4 seconds. So the time for that flight is 6.4 seconds.
Where is it?
Question 2, a projectile is fired from the top of a 120 metre high cliff at 25 metres per second. It lands on the ground 6.4 seconds after falling. Okay. Now, as I always urge you to do, we put our data in there. And of course, you can always start with AY equals minus 9.8 metres a second minus 2. We can put in AX, because it's a typical question we have in the HSC, it's 0. We can mention the fact that we know the initial speed of the thing, which is 25 metres a second. We also know that time, yep, is 6.4 seconds, and delta Y, it's not its maximum height, but the height difference from where it started to where it finished is 120, but I'm just going to move that, not that bit. No, I wanted to. Okay. I'm just trying to undo the little capture. I'm not sure how you do it.
Oh, yeah. You sit somewhere else. Tap somewhere else.
Undo. Hit the undo button.
Which undo button?
Usually you hit this control thing.
Control Z, sir. Control Z.
It's alright, I can do it like this.
How are you going to get rid of this now?
Don't touch it now. Okay, so I've rewritten it, but I'll put the minus 120, okay? Because if that's being fired that direction, we call that upwards, and I'm defining that direction as plus, which must mean that direction is minus, and it means that from the starting point, it's gone minus 120 metres. Yep.
But you're not, are you thinking in fact that it's not flying directly sideways, it goes upwards?
Doesn't matter, because with the formula, and the formulas build that into it. So, because of the influence of gravity, when I fire it positively, it takes 6.4 seconds to go up to that height, and then to go down to minus 120 from where it started.
It's almost like
So,
3 in 1.
yeah, so you're allowed to use a minus 120 in that formula.
So
Okay.
you calculate the first part, then it starts to go down.
Yeah.
Because you got the 120 when it...
I'm just
weird.
confused.
In 6.4 seconds, it goes from the top of the cliff
Yeah.
and ends up 120 metres below where it
So
started.
the change from 1 is still 120 meters. Yeah, okay.
Yep, that's exactly right. And that's a little trick to realise for solving these questions. You don't have to calculate how high it goes from there and then add it to 120 and do all the rest, which is what some students try to do. You can just put minus 120 in and it'll work quite well. So we'll look at the questions I ask you. I'm just going to stretch my area so I can work nicely. We're going to start with question A, which is the initial velocity of projectile. And of course, this is a question if you're in the HSC, they may ask it. They aren't likely to, but they might. And this is a question for students who they think we're going to get 5% in the exam. Because they ask you what the initial velocity of the object is, what is it? 25. You just read out the question. Okay. Question 2, or B. They ask you to find the initial horizontal velocity. Can you do that? From that now, immediately? Probably not. So I'm going to leave that. And I'll leave a little bit of space to do some calculating with. C. Initial vertical velocity. Is that easy to find? No. So I'm going to leave that one. D. Range. I'll put, just to remind me, I'll put UX, UY, range, delta X. Not easy to find. So I'm looking for an easy one to do, yeah.
Question like that, will it reach its max point halfway through or not?
No. No, it won't. It'll reach its... if it was going to land back there, this maximum height would be halfway through the journey to get to there. But as you see, there's a whole lot more to go. You can, but you don't need to yet. We'll go through that. Okay. E. Maximum height above the launch position. Okay. Sorry? Just made that up. So I'm going to call that, you're going to give it a name. Let's call maximum height delta Z. Can I work that one out? What happens at delta Z? What do we know about the velocity? Be 0, won't it? Okay. Can I use that information to find its maximum height?
Delta Z.
Yes, I'm just calling it delta Z for convenience. I could call it anything I want. These things are not set in concrete. As long as I label it, I can call anything I want. But I'm just using that as a label for the maximum height above the launch point, right? And that's what the question is. So delta Z equals UYT plus a half AYT squared. Is that useful for us? Can we do that? But we don't know, we do not know that, so we're a bit stuck.
What do you mean the plus and minus this?
So, I've actually skipped a step there. What that means is that I'm calling that positive direction, and I'm calling that negative direction. But I do know at that point, Vy equals Uy plus Ayt, don't I? But I'm stuck still.
Yeah, I tried to do that last time. I was doing a question where, like, because, I didn't.
So, is there anything I can do using the formulas that I have? This is what we're trying to find out.
Well, maybe it's just another question that we can answer.
What do people think?
I mean, you've got about some of the time it takes to reach maximum height.
Can we do that? We don't know what the maximum height is, do we? Yeah, how did you get 7 out of it though?
It's guess.
You just guessed.
We can do the one in red.
Which one in red? The velocity is in red.
People aren't looking. Let me just show you this. If I make that delta y equals UYT plus a half AYT squared, I know that. I know, oh, that's what I want to find. I know that, and I know that.
And then you can just sub that into it.
Then I can just start subbing that into other things, can't I? So I'll show you how to do that. So my delta y, And notice they actually don't ask this question in the set of things I ask you there. It's something you're going to have to do on the side to get the key to answer the questions. So, well, so yes, I've only written UX because I can't answer it yet. I have to come back to it. All right? So, before I can do anything they ask me to do, I actually need to do a little bit of other mathematics using the delta y. Let's just move that over. Oh, let's just rub that out. I'll move it over. So we saw that delta y equals uyt plus a half ayt squared. So this is a classic case I was talking about before. You can't do anything else, so you do this. And then you see how it works. So minus 120 equals uy times 6.4 plus 1/2 times 9.8, and I'm not putting the units in because of 6.4. So now I can do some rearranging, which will be.
So, how would you tell when to put in the negative 9.8 or just the 9.8?
Oops, that should be negative. You're quite right. Thank you. Why is that dropped out?
Because you fit the power on the smart touch out back.
Minus. It's back. So it's actually minus 9.8. You're quite right. It's a mistake that I think we picked up yesterday doing it. So you're going to end up with uy equals, well, I can write out like this, minus 120 minus 1/2 times 9.8 minus 9.8 times 6.4 all over 6.4. I've got a minus there.
Isn't it also 6.4 squared?
Correct. Squared on the end. Thank you.
That's minus 120 on that side from the equal, but when you fill that out,
All I've done is I've left the uy there. So I've got the minus there, and I've subtracted this bit from it. So minus 120 minus 1/2 times minus 9.8 times 6.4 squared.
yeah, if you're moving it from one side of the equal sign, it should be a positive.
I haven't moved it from the other to the other side of the equal sign.
Just kept the
I've kept the uy there, and I've moved all this stuff across that side.
why is it negative?
It's negative because that's the positive direction. I started there. I've gone 120 metres when I finish. That's where I finish up. I finish up 120 metres from my origin in the negative direction. So when you do that, and I did do it yesterday with Riley, and I forgot what the answer was now. So you get a calculator out, and I will grab a calculator out and I'll quickly find an answer for you. So 0.5 times minus 9.8 times 6.4 squared equals, so that's, and then I have to no, I haven't moved 120 to the other side.
You moved the other side.
I moved everything here to that side. So now it
One way
becomes,
didn't move, everything moved to the 120.
yep. So we end up with minus 120 plus 200.704 all over 6.4, which equals,
Yeah, we looked up in it.
Did you get
12.61.
I got 13.40 yes.
I'll just check it out again.
So what's this 200 from that one?
I still got 12.61 as an answer.
No, but 200 point.
704 divided by 6.4.
9.8
That's like 6.4 squared.
No, it's not factorial.
It looks like
So I end up now with uy
You can find UX.
equals 12.61 meters a second, which means that now, as you said, I can find ux. And if I was going to find ux, which I have down here, it's simply a matter of I have a resultant vector like that, which is going to be 25. And I know uy, which we calculated to be, yes, we've got C, I've just put in. That means I've got 12.61 there. Now what I need to do is find ux, which is that part there. And of course that's simple Pythagoras, isn't it?
C squared.
So using Pythagoras, which would mean that 25 is going to equal the square root.
Answer not in square root gives the 21.6.
So you've done that in the calculator form.
Yeah.
So ux equals 21.6. Thank you for doing that. That shortcuts a whole lot of stuff for us. Right. Having done that,
So how did you get 200? Oh, did you
That's-
107.2? Negative a half.
200.704 is what I got.
Negative 0.8 on 6.6 squared.
That's part there. Now maybe I've pressed a button incorrectly on my calculator and done something silly.
Was it 9 minus 9.8 times 6.4? Yeah.
That's correct? Good. Okay.
The range equals 138.2.
So range is simply uxt. So that's simply going to be the 21.6 times the 6.4. What did you say it was? 138.2. And then this delta z question now starts to become easy, doesn't it? Because in delta z, it's just simple substitution. We know delta z equals, we've got uy, which is 12.61, times 6.4 plus 1/2 times minus 9.8 times 6.4 squared. And you, that's the height, maximum height above the original part. Okay, that's that delta z I was trying to work out. And I have a formula now where I know uy, I know t, I know ay, so I can just put the numbers in, you just plug it in your calculator. It's an easy question now.
But you didn't take into account that fell last time.
I don't have to at this point. I'm only been asking the question, its maximum height above its launch point,
Yeah.
which is from there to there.
Yeah, that
Actually, sorry, I'm glad you said that, Tom. I've gone to sleep and so has a class. I have to edit that out in my recording. 6.4 is all the way down there, isn't it? So I can't do that. But what I do now have,
Yeah, I read it last night. No, I don't.
what I do have it first up, the thing I'm missing is the time. You're quite right, Tom. I should have been awake to that. But what I do have now is a mechanism of doing this, because I know that when it gets to its maximum height from its launch point, Vy is 0, Uy starts off as the 12.61, minus 9.8 times time. So now what I can do is I can work out the time it takes to get up to the top there. So it's now going to be T equals 12.61 on 9.8. Yeah, well, they're both minuses. Yeah, because I take the 12, you take that over there, which makes a negative, and then you divide by it. So when you do that, you're going to end up with a number of something at 1 point something. 12.61. 1.37?
Why are you doing this? Why not?
Yeah, because that's fine.
Yeah, 1.3.
But it needs to just go.
1.29 rounded. That's really close.
Okay, so now I can fix up my error from up here. Let's move all that out of the road. Get out of the road. Line by line. Oh, that's interesting. Get rid of it. So 1.29. So now I have t, I can actually finish off. So delta z, as I said, was the uy, which is the 12.61 times 6.4. No, it's not 6.4, I'm saying. Times 1.2867.
So do you reckon that this sort of topic will like help us, because projectile motion is one of the topics we do in extension maths as well?
It will help, yeah. So you put that in, and I'm not going to put my, probably I should do it in the calculator to get it right. 12.61 times 1.2867 plus 0.5 times minus 9.8 times 1.2867 squared equals, I get 8.11 metres. Okay, 6.4 seconds takes me from that point all the way to that point.
Yeah.
It only took a short amount of time to get from there to its maximum height. And I had to find that because the question was how far above its firing point did it get to? So I need to know to solve the equation, I need to know how long it takes to get to that height, and then I can plug it into this equation and it tells me that it went 8.11 metres above its firing line, and then it fell, so its total distances fell from that point to that point is 128.11 metres.
Delta Y the whole distance.
Delta X.
Whole height.
Oh, delta Y. Look, as I said, you need to define what it is. I defined delta Y this time as the height of the cliff.
What do you call the total?
Well, I called that little bit delta Z. I could call it delta alpha for all that matters.
Could you call it delta? Delta is very classic.
Could call it delta. You could call it just delta Z plus delta Y if you want. It's up to you. What you call it's not super important. It's knowing what you call, what those labels mean, and then doing the calculations is important.
Wait, so do you minus 124?
Well,
We did F, sir, by finding the...
yes, by finding time we did F. That's right. So that's that question done from beginning to end.
So if you keep
We already
practicing,
had F.
Have we done G? G is its time of flight.
Yeah, that's the 6.4. So you can see, you can answer almost any question. It's just a matter of patience. And in this particular one, the particular trick with it was that we needed to do something which we weren't asked to do in the questions. So if you looked at A, B, C, D, E, F, G, H and I and you tried to answer those, you literally couldn't do it. What you needed to do was you needed to go and look at your formula and say, I can do that, and then that result gave you something that you could then plug in and use to answer the rest.
so that's why there's 5 of them. There's not just like when I had a look at the first thing, I thought, oh
Yeah, this is a question I do in the HSC occasionally in various forms. I've seen it in 3 different ways so far. So let's try and draw it. First part is you have the ground, and you have 2 people throwing a ball and they have a strobe light. And what you see with the ball, and I haven't drawn it in a spot I can do it, so I'll do it again. No, you have that. You have this dot point, this sort of strobe light effect. And then they label it. One.
Is that the question? Acceleration?
Mm-hmm.
Is that the question? That's the starting point?
questions for the hardest.
This is the one they put in. This is not the hardest. This is a question that's commonly there they use to trick students.
I know this for someone like
That's just like, yeah. I got sandstorm stuff in my head. What's that? Sandstorm.
Okay, that typically is the sort of question you might see. It's happened 3 times in the last 8, 9 years, something like that. Where's the maximum acceleration?
Let me try. X.
It's always
It's
under
Y.
acceleration.
No,
In between
like
X and Y.
No, we see.
Listen to Brad.
But that's.
say.
Oh, so is it? It's not multiple choice. It's
I've sent it as short answer. I've sent it as multiple choice.
oh, so if it's a short answer, like if it was multiple choice, they'd be not the acceleration is constant.
Yes,
So
and that's the answer. The acceleration is constant.
would you tell that from how many points it's worth?
No, it's just because once it's been fired out of whatever's launched it. Yeah,
What about the y-axis?
Y is always minus 9.8 meters a second.
that's right. And there's no x acceleration, so it's constant. Next one. Where does v equals 0?
Why?
Z.
Which V though?
No, y.
Oh, Y.
Sir,
Y
which
easy.
V? Because
Hmm?
it doesn't specify what.
Just the velocity through its journey.
Is it talking about
But
X
it's also
velocity or
still
Y
going
velocity?
sideways.
Where is the velocity 0 in this diagram?
Y because X still has
Still going
velocity.
sideways.
Oh,
It's a trick question.
Z.
No, because z's above the ground.
What are the
Oh,
options?
because it's under negative acceleration.
What's the letter before X in the opposite?
The answer is to this. There is no point at which has 0 velocity.
You got to at least give
That's not a
Yeah, we
question.
know.
These questions are
Out of X,
prepared.
Y, and Z, where does it have 0? Oh, none of them.
That's right. Watch for these questions. Sometimes I ask questions to see whether you're awake enough, not to assume that one of them has to be right, but actually if you're a physicist, you go, these guys are asking silly questions. They just try to do things in my mind.
Alright, so
Could you
does
explain
E
what-
stand for energy?
Why what?
Can you explain why it's nowhere?
Because even at Y, it stopped going up, but it's still going sideways.
Z looks like it's on the ground, sir. It's not on standard.
I'll fix it.
Oh.
Now it's not on the ground.
You'll like that, sir. I can tell.
Yeah, that's pretty special. Okay, which point is E the greatest?
Is energy the greatest?
It's almost constant.
Constant. There's no point in that journey because you're just going to change in energy across it from kinetic to potential.
So the first 3 questions have all been constant.
Yeah.
Except for the second.
Number 4,
Kinetic energy is the greatest. Z.
Z, correct. Because it's a lower level than, sorry, yeah, kinetic. It's a lower level than X, so it's got the greatest velocity at that point.
That's actually not too bad.
But I thought,